Hello everyone and welcome again. In this video I want to go over some homework problems and do some examples, probably 3 or 4 of the homework problems. This is maybe the first video. I'll do more videos on solving examples of differential equations. So now before doing those problems, let's go over how to solve different differential equations. So a differential equations, so equation is written like that: y prime equals to dy equals to f of x y. Now to make your job easy, and I saw that in another video, and I think it's helpful. Just remember shields. So that's a mnemonic that's gonna help you to remember different types of equation. What does shields stand for? So the types of differential equations you can have: S stands for separable. So separable, if you see a differential equation is written like this: dy dx equals to g of x times h of y, then you can separate the variables and solve it. Then we have H. H is homogeneous. A homogeneous equation, you can take a look at the lecture. Usually that's what you have, or if you have m of xy dx plus n of xy dy, and m of tx and ty can be written as t to the alpha m of xy, and n of tx comma ty can be written as t to the alpha n of xy. And again, this is not 2, these are alphas. So I think that's better. I stands for integrating factor, and integrating factor is that, and that's used for linear equations, and we're getting there. Just to remember this one. Then you have E. E is exact. An exact equation is m of xy dx plus n of xy dy equals to 0, and it's exact if this is satisfied. And remember, we use these two equations to solve for exact differential equations. Then we have L. L is linear. A linear equation can be written as a1x dy dx plus a0x y plus g of x, or you can just write it like that. And again, that's where we use the integrating factor to solve the linear equations. We come up with the product, and then we solve it. Then we have D. D is direct. Is when you have y prime equals to f of x, or dy dx equals to f of x, or dy equals to f of x dx. So just a simple integration. Then S stands for substitution. We use substitution for homogeneous and Bernoulli's equation, and there's another special case, but homogeneous, you already have it here, and Bernoulli's is written under this one. You can check the lecture on that and see how it's solved. Now let's go over some problems. I picked number 11. So solve 1 plus x to the 4th power dy plus x times 1 plus y squared dx equals to 0, and we are given an initial condition or initial value: y is 1 equals to 0. So when you write this equation, if you're not sure which one you're dealing with, you can isolate dy dx, and we know we have a function of x and a function of y. So this is like g of x times h of y. So we know right away this is separable. So what you can do is separate the variables. So you can divide both sides by 1 plus 4y squared. So you get dy over 1 over 4y squared. And you can take, well, first of all, take that to the other side, to the right side, or subtract this term from both sides. So you get that, and you can divide both sides by 1 plus 4y 4y squared and 1 plus x to the fourth power. So that's what you get. And for differential equations, we know we have to get the integral of both sides. Now what I did the integral, try to do it step by step here. To solve it, the left side, dy over 1 plus 4y squared, you can write that as dy over 1 plus 2y squared. And here you can do for number one a substitution. U equals to 2y, du equals to 2 dy. So dy is 1/2 du. If you substitute, you get that. And this is trigonometric substitution, although it's very common. This is tangent inverse, but let's kind of refresh our memories of calculus too. You can take u equals to tangent theta and du equals to secant squared theta d theta. And we know you can write that this as du secant squared theta d theta, and the denominator is 1 plus tangent squared theta. But what is 1 plus tangent squared theta is just secant squared theta. From trigonometry, again, Pythagorean identity. So now secants cancel each other and you're left with 1/2 d theta. And the integral of that is 1 over 2 theta plus c. And if you make the triangle here, please refer to calculus to trigonometric substitutions, and you can remember this. But if you make the triangle, tangent theta is opposite over adjacent, u over v, and of course the hypotenuse is square root of u squared plus 1. And you can find any of them, but here all we need is u equals to tangent theta, so theta equals to tangent inverse of u. And we know that u, we substitute that by 2y, so the answer will be 1 over 2 tangent inverse of 2y plus c. That's c. We won't use it when we solve the differential equation, but let's go over the right side. The right side of this equation, that's what we have. So negative x dx 1 plus x to the fourth power, you can write that as x dx 1 plus x squared negative 1/2. Then you can say u equals to x squared, du equals to 2x dx. So if you substitute, you get du over 1 plus u squared. And same way, this is tangent inverse of u plus c, and we know u is x squared, so you just substitute. Coming back to the answer of the equation, so the left side we got that, and the right side we have this one, negative 1/2 tangent inverse of x squared plus c, and you can just have 1c is good enough for both sides. Now if you multiply both sides by 2, you get tangent inverse of 2y equals to negative tangent inverse of x squared plus 2c to get rid of those or isolate that. If you take the tangent of both sides, you know tangent inverse, it's gone, you're left with 2y equals to that expression. You can isolate y by dividing both sides by 2, and that's what we get. Now we know this is given, an initial value is given, so you can substitute when x is 0, when x is 1, y is 0. So let's substitute. So you get 1/2 tangent, negative tangent inverse of 1 plus c, and that should be equal to 0 because y is 0 in this case. Tangent inverse of 1, we know it's pi over 4. It's an angle. So you get 1 over 2 tangent negative pi over 4 plus equals to 0. Tangent equals 0 when the angle equals to 0. That means negative pi over 4 plus equals to 0. You solve for c, and c equals to pi over 4. Now if we substitute, we get 1/2 tangent, negative tangent inverse of x squared plus pi over 4. We can write that as 1/2 tangent pi over 4 minus tangent inverse of x squared. Again, recall from trigonometry, tangent a plus b is tangent a minus tangent b over 1 plus tangent a times tangent b. So a in this case is pi over 4, and b in this case is tangent inverse of x squared. So you can substitute, so you get 1/2 tangent pi over 4 minus tangent inverse of x squared, 1 plus tangent pi over 4 times tangent inverse of x squared. And tangent inverse of x squared is just x squared. Tangent pi over 4 is 1, and that's also x squared. So you're left with 1 over 2 times 1 minus x squared over 1 plus x squared, and that's the answer. Next one, number 6, we have solved 1 plus x dy minus y dx equals to 0. Again, here you can separate the variables, so it's a pretty easy integral differential equation. So you get dy divided by y and divide by 1 over x, so you get dy over y equals to dx over 1 plus x. Take the integral of both sides, ln, this is ln absolute value of y, and this side you get ln absolute value of 1 plus x plus c. And if you change it to exponential, take the base e, so you know e to the ln absolute value of y, then here you get e to the ln absolute value of 1 plus x plus c. However, please remember this all the time because you're going to see this a lot. What we use is a to the power of m plus n is a to the power of m times m to the power of n, and that should be n, and that's how you can write it. However, e to the c is just a constant itself. I kind of put capital C here. So instead of e to the c, you can just write c, substitute c here. So what you get is absolute value of y equals to 1, absolute value of 1 plus x times c. Now what is, we know we have to put plus or minus, but we can say you have a constant here, c, that can be plus or minus. So you can take the absolute value out. You don't have to write it like that, because that c can be negative or can be positive. So you can just leave it as c times 1 plus x, and that's the answer. Next one, number 7, dy dx equals to y squared minus 4. Separate the variables. Again, this is, if you isolate dy dx, that's what you get. So basically, this is your f of x, and that's your h of y. You don't have to do that if you see it's what type of equation is that. So you write dy over y squared minus 4 equals to dx. Now, how do we solve this one? 1 over y squared minus 4, you can factor the denominator, and you can do partial fraction decomposition is a over 1 minus 2 plus b over y plus 2. Now this side, if so you have that equals to, take the LCD, and you know you have to multiply these two, so you get a times y plus 2 plus b times y minus 2. And set the numerators, we don't need the denominators anymore. Set the numerators equal to each other, so we have 1 equals to a times y plus 2 plus b times y minus 2. Now you can, what we want to do is solve for a and b. You can make the system, review your partial fraction decompositions, please, or there's another way to do that. If you set y equals to -2, then what you get is 1 equals to a times -2 plus 2 plus b times minus 2, -2 minus 2. And this is just 0. So you get 1 equals to -4b. You can just isolate b is -1 over 4. If you say y equals to 2 or set y equal to 2, then if you put 2 minus 2, this becomes 0 in this case. So you get 1 equals to 4a, a equals to 1 over 4. So basically 1 over y squared minus 4 is 1 over y minus 2 times y plus 2, and it's that. But now we have our a and our b. We can write it 1 over 4 times y minus 2 minus 1 over 4 times y plus 2. Coming back to our differential equation. So now this side, you can separate them. So it's 1 over 4 times dy over y minus 2 minus 1 over 4 times dy over y plus 2, and that equals to dx. The integral of dy over y minus 2 is ln absolute value of y minus 2, and that is minus 1 over 4 ln absolute value of y plus 2, and the integral of dx is just x plus c. So now let's multiply both sides by 4 here. And let me write that. So if we do that, we get ln y minus 2 minus ln y plus 2 equals to 4x plus 4c. So ln absolute value of y minus 2 over y plus 2 equals to 4x plus 4c, which can be a good answer. But if you want to solve this explicitly, let's go ahead and do that. So now let's pay attention to this constant. 4c itself is a constant, so I call that c1. So I can say it's 4x plus c1. Now if you change this to exponential form, or you do e and e here, so you get absolute value of y minus 2 equal over y plus 2 equals to e to the power of 4x plus c1. One more time, you can write that as e to the power of 4x times e to the power of c1. And e to the power of c1 is just can be a plus or minus a constant, and you can just call that c. You don't have to put that plus or minus. If you do that, then you take the absolute value out, and you can say y minus 2 over y plus 2 equals to c times e to the power of 4x. And all you have to do is isolate y. So cross multiply, and you get y minus 2 equals to c to the power of 4x times y plus 2c e to the power of 4x. Take all the terms with y to one side. So y, so it just subtract c to the power of 4xy here, and I wrote that as negative 2yc to the power of 4x. Take the 2 to the other side, or add 2 to both sides, so you get plus 2, factor out y, and divide both sides by that expression, and that's really good. That's a very good answer. Or you can just write that as 2 times 4x plus c. It doesn't make any difference. So that's a good answer. Next one, number 80 to the power of 2y minus y cosine x dy dx equals to e to the power of y 2x, and you are given the condition y of 0 equals to 0. Same thing, separate the variables, so you get e to the power of 2y minus pi over y, dy equals to sine 2x over cosine x dx. Separate them, so ey over e to the 2y over y minus y over e to the negative over ey over e to the y. That's how you can write it. When you divide, you subtract the exponent. So here you have e to the y minus y e to the power of negative y. You can take it up and change the sign of the exponent. This is just algebra. From trigonometry, remember sine 2 theta is 2 sine theta cosine theta. So change sine 2x to 2 sine x cosine x over cosine x. So cosines cancel, and that's, you are left with 2 sine x. Now you can you have two integral. The first one is just e to the 2y, and that one you can solve that by parts or the shortcut. You take that y, and again on the right side you do the derivative, and left side you do the integral. So you start with y. The derivative of y is 1. The derivative of 1 is 0. Then the right side you take that e to the power of negative y. The integral is going to be negative e to the power of negative y, and one more time you get e to the power of negative y. To get the answer, you just multiply with plus sign, and the second one is going to be negative. Or you can do this by parts. This is just a shortcut, the tabular method. So e to the power, the integral of e to the power y e to the power of negative y dy is that times that, the plus sign, but it's negative, and it's minus that times that. So that's where I substituted here. distribute the negative sign. That's what you get on the right side, and that's what we have on the left side and right side. Apply the initial value, and y of 0 is 0. So whenever x is 0, y is 0. So you just substitute, and again, this is very easy. Cosine 0 is just 1. So solve for c, and c is 4. So the final answer is, this is implicit. You can't find y explicitly here. So just leave the answer like that. Y e to the y plus y e to the negative y plus e to the negative y equals to negative 2 cosine x plus 4. Now, I think that's the other examples, homework problems. You should be able to do it yourself. Try those and make sure to review again technique of integrations, partial fraction decompositions, and of course trig identities. That's what we use a lot for this course. That's it for this video. Hope you all have a good one, and I'll see you in my next video.